Welcome back. So let's answer the questions for this problem. In the problem, we were crossing two heterozygous black hybrid round plants. And like I said, I color coordinated these boxes based off of the different genotypes so that it was easier for me to count up what those genotypes were. Now, this is the one exception to wanting to use a fraction for my ratios, because I can easily count up all of those numbers and count up to 16 and know that I accounted for all of my boxes. And I would also encourage you not to simplify these again so that that top number adds up to 16 and you know you counted for all of your boxes. So if you look at the Punnett square I have in the bottom corner, I only have one box that's homozygous dominant for both black color and shape. And so I'll write down that genotype, homozygous black, homozygous round, and it's in one box, so I write it as the fraction 1 over 16. Then I go across the top and I go to the next box. The next box is homozygous black, heterozygous round. And when I look at all of my different boxes, I find that in two boxes. So I write down that genotype and the ratio 2 over 16. Again, note I did not reduce that fraction. Okay, move on to the next box. Heterozygous black, homozygous dominant round. Two boxes, so 2 over 16. Go to the third box, fourth box now. Heterozygous for both black and round, and I have that in 4 boxes, so 4 over 16. Okay, so now I can go to the second row, and I did this one, so I move on to the second box in homozygous black, homozygous round, wrinkled, that one. So 1 over 16. I did the heterozygous ones. So heterozygous black, homozygous recessive round, 2 over 16, because it's also down here. Next row, I did this one. I did this one. Okay, so that leaves me homozygous white, homozygous round, 1 over 16. Homozygous recessive, heterozygous, 2 over 16. And lastly, the last box, which is homozygous recessive for all, 1 over 16. Okay. Yes, that's a lot. 7 different genotypic possibilities. Now, when it comes to phenotypes, it's a little bit easier. There's only 4 different possible combinations. You can either be black and round, black and wrinkled, white and round, and white and wrinkled. So when I count up the number of genotypes that would be black and round, I have 1 here, plus the 2 here, that gives me 3, plus the 2 here gives me 5, plus the 4 here gives me 9, and if I look, all of the other genotypes don't give me any that are black and round, so that's 9 over 16 that are black and round. Then I move on to the next possibility, black and wrinkled, 1 over 16, plus another 2 gives me 3 over 16 black and wrinkled. Next possibility will be white and round. I've got this one plus these 2, so white and round is 3 over 16, and that leaves me with the very last possibility, which is white and wrinkled, 1 over 16. Now this is the most complicated Punnett square you will ever have to do for a dihybrid, which would be crossing 2 parents that are both heterozygous for each trait. If you can do this problem and you understand how to do this problem, all other dihybrid crosses will be a cinch. So if I have not yet popped in, I will be coming in, and if you have any questions, feel free to ask.